Hey everybody, this is Alex Merced from alexmercedcoder.com, and in this video what I want to do is just talk more about learning Scala. Okay, cool. So let's do that. So in the last video we just kind of talked about like installing Scala, setting up your Scala environment, the basic structure of a Scala program. So again, it's going to be a lot like Java, where basically each script or each file is essentially, in this case, called an object, but essentially a class definition. So here we're defining an object called Scratch, okay, and which has a main method, and the main method is the entry point for the program. We can compile it, then we can run it. Okay, so right now I have a method called hello that I can use like so. That's a function. So again, writing functions is a lot like Python in a sense, where you have the def keyword, except it's the syntax is a little bit more like, let's say, like JavaScript or Java or C++ with the curly brackets. What I'm going to talk about in this video is more like control flow, like essentially how do we do if statements, loops, things like that, which is pretty much, if you've done most programming languages, it isn't going to be all that different here. So for example, if I have, let's declare a value called x that equals 5. If I were to do if x is greater than 3, and then say print line, x is greater than 3, then yeah, let's try that out. That should work. So then what I would want to do is I would want to compile it. So I would do Scala. I'll just do that, scratch.scala. So I'm going to compile with Scala C, that's the Scala compiler. I'm going to compile the file. Cool. And then that's going to compile into these class files that always match the name of the object, which is another reason you always want the object to match the name of the file. So you can see here, since I didn't make it a perfect match, see this is uppercase, that's lowercase, object name should generally be uppercase, or the file name should have been uppercase. Notice that the class files don't perfectly match. Okay, so that's the only reason you'd want to, just it makes it easier to track everything if everything is consistent in its naming. Cool. But then I could just run it by doing Scala and then the name of the class, Scratch. And then what's going to do is going to then look for a class of that name and run it. And basically run it using its main method as the entry point. And see x is greater than 3. Now what happens if I change this to 2? Okay, so let me add an else clause. Else print line x is less than 5 or less than 3. And cool. I should probably put some semicolons here just in case. I don't think this seems to be so far as quite as nitpicky about semicolons as Java. So once again, I'll compile the file. Then I'll run the file. And there we go, x is less than 3 in this situation. Cool. Easy peasy. Okay, and now notice that whenever you have any of these like compile programs, really any script, and you have this main function receives any arguments passed in via the command line. Let's see what that looks like. So I'm going to print line. Let's see if this lets me just print the array. So I want to print args so we can see what args is. Okay, so let me compile the file. I should probably put a semicolon in there. Assuming printline will let me do that, because it is strictly typed, so I'm not sure if it'll just let me print an array like that, but we'll find out in a moment. Okay, looks like that will work out. Now if I just do Scala Scratch, okay, so we have Java lang string. Now if I do this, these would technically be arguments. Hello, cheers. Okay, so it's just giving me the address of the object. So let's do this. And I think in Scala arrays, indexes are passed through parentheses. So again, if you come from newer languages where it's always done with square brackets, that is kind of annoying. But again, if you use like C, C++, not too much of a stretch. Args 1. Okay, so let's see here. Let's compile that. Let me do it with the 2 arguments. Print line arg0 dot lang string. Did I not recompile it? Maybe this doesn't work the way I think it does. Maybe I can't pass multiple arguments. I should be able to pass multiple arguments to print line, but let's try this. Or actually, let's do this. You can loop over something. You can loop over an array like this. If you've ever seen like a for of loop in JavaScript, where I could do for like x of, in this case, args, the way it works here would be x of, and I think the arrow goes this way, so it would be like an arrow of args. And essentially that's saying, hey, it's like loop over args. And every time it loops, x is going to be the item in the thing that it's unpacking. And then we'll just print line x. Okay, let's see if that all works the way I'd like it to work. So let's compile it. Oh, doesn't like that. Expected error. But expected found. Oh no, yeah, because that should be 4. My bad. It's a loop. So you can tell I just woke up this Saturday morning. Okay, that compiled correctly. Okay, generally if it compiles correctly, that means your code at least is not syntactically broken. And there you go. See, so notice what happened here. I am logging hello and cheese, or I'm printing hello and cheese. Now where did hello and cheese come from? Because it's nowhere in my code. It's coming from these arguments. So I could pass my Scala script's arguments, and I have access to them through this array. Okay, so that's fun. Now I'd still like to be able to access just like one of the properties. So let's go back and take a look. See if I was making any mistakes in the way I was trying to access one of the properties. So, okay, if we're going to the array section here in tutorials point. I always like tutorials points. A good place to kind of get started when you're learning a new language. Okay, so here we see the different ways we have arrays. That's all fun and good. Well, that's just kind of what we just did. I just want to print one element. Okay, total. Let's just see an example. Printing an element without having to loop over it. That's printing a 2-dimensional array. That's still looping over the array. Okay, let's see here. Nope, that's still printing. That's still iterating. Let's see here of these images. Range, tabulate. Concat creates an array of t objects. I just want to get one item. Returns an array of 0 length. Returns an array creates an array with given dimensions. That's all fine and good. Range, concatenate arrays. That's all fine and good. Because all the elements in an array are the same type, as an example. But what if I just want to access? Well, yeah, so that's what I was doing before. So let's try this again. Okay, what if I want to print line and I want to print args 0? I just want to print the first argument. Theoretically, that's the way it should be done. So let's compile. And this is always the way you want to learn stuff. You experiment. You make assumptions about what things should be, and you keep testing those assumptions. Okay, so yeah, that is how it works. I don't know why it didn't work before. I must have not compiled it. But yeah, so you see there, hello. This is from the loop. This is from the print line on line 9, and here is the if statement. Okay, so we've seen how the loop, or at least how the loop over a collection of items. So like if you're looping over an array, there's also something called a list. A list is basically a linked list, and it's going to be just like a little bit more flexible array. Now, again, if you've used like JavaScript, Python, Ruby, you're probably used to arrays being like super flexible. Like you can add items to them, you can subtract items from them. Not here. This is more a little bit more higher, like the higher level languages, like with C, C++, Go, Rust, where arrays are fixed length. Okay, they do represent like a sequential block of memory. So in that case, you can't really add to it because you don't know if something else has been added after that sort of location in memory. So they're all like next to each other. There is a linked list where, again, what you're doing instead is you're linking chunks of memory. Okay, so basically the different items can be all over the memory, and they all just have pointers to each other. And in that case, you have a much more flexible length, although they're not as fast because, again, they're not sequential blocks of memory. So this is where when you start dealing with like higher level languages. I'm not saying Scala is quite as high level as, let's say, something like C, C++, but you start caring more about sort of like your data structures, because your data structures can affect the speed of a program, and especially when you're dealing with things like trying to take huge data sets and process them very quickly. You want to be able to think through that and be able to actually like work with arrays in a way that you can optimize that speed and create data structures that will lend to faster processing. Okay, so that's why Scala is like very popular with data. It's not quite as verbose as Java. It works in Java, so you could use it in terms of like things like Hadoop and Spark, which is going to generally be sort of like the main reason you would use Scala. You can use it within the Java virtual machine, but again, it's not so abstract. It's so high level. Okay, high level means more simpler languages like Python, Ruby, JavaScript. Low level means, and I think I was using it in reverse earlier, like a few minutes ago, but low level would mean more like not as abstracted languages where you're dealing more with sort of like how the computer works. The most low level language being machine code, of course, if you really just want to write a bunch of zeros and ones. Okay, so again, just to recap, we can do if statements. Again, they don't look all that different than you're used to. You can do loops, and I'm pretty sure you can just do standard for loops as well. Let me just double confirm that. Loop statements. Is anything too different there? While true, yep, while true works the same way. Wait, do we have for loop statements? I'm pretty sure we do. While, do while, for loop. There we go. Okay, that's just for an array. Can we use just a standard for loop? No, not at all. Okay, so this looks like you have a while loop to do your traditional looping. So if I wanted to loop like 10 times, I would just use a while loop. So I would do this. Let's see here, like I would want a mutable value, so I wouldn't use var. So I'll say var counter equals 0. And I would say while counter is less than 10, then we will print line counter. And then after each instance, we will increment counter. Okay, I'm pretty sure that the increment operator is in this language. And then let's compile and run. So compile. Oh, doesn't like that. Nope, I guess not. So in that case, we will use plus equals, because that's always around. That just means add 1 to counter. That's a better way of doing it anyways. Cool. And then we'll run the file and see where we get the loop. See, it loops and repeats the line. So long as its counter is less than 10, it repeats, and it's only adding 1 to counter on each loop. So it loops that many times. So if I'm looping over a collection, I can do a for loop kind of like this. So like if I want to loop over an array, loop over a list, I just take that list and just point it to a variable name. And again, I can call that variable whatever I want. And there you go. So yeah. So you can see like control flow doesn't really change all that much here. You can also do what's called a match statement. which is essentially what's called pattern matching. It's kind of like a switch, except the way a switch works is that you can run some code if the value you're testing matches the case, and that's it. Now, with pattern matching, which is now just got added to Python, exists in like Rust, most of the functional language, which Scala is considered in that category of functional languages, generally have a pattern matching feature. So if you use like OCaml, I think probably Lisp. I haven't used Lisp that in depth to know for sure that it has pattern matching. But Haskell, any of those languages, they generally are going to have a pattern matching feature, which is like, again, like that switch statement. You're saying, hey, does this value match? Except it's not just like a straightforward, like, does this match this value? It's more like, does it match this pattern? Which allows you to do a lot more flexible, cool things, which makes any language that has pattern matching really great for like parsing, especially if you're like parsing like large data sets and trying to see like, is this true about them? Is that true about them? Other than like, do they equal this value? Like, do they match this shape? Are they this type of object? All sorts of different cool things like that. So let's take a look at pattern matching. Okay. Usually you use a match keyword and then you kind of specify a bunch of possible cases. But off the top of my head, it's escaping me. So like here's like the syntax. Okay. So essentially what would happen is that you would say match, and then you would match here. Okay, so in this case, they're defining it as a method. That's interesting. Okay, so it's like, is that generally how you do this? Oh, okay, that's an interesting way of doing it. So this is like a special type of method. So it's not like just a freestanding control flow mechanism. You're essentially defining a function that matches. Let me just see if that's consistent with all the other places I see match. Like here, I'm not seeing. Here, they're actually just using a match freestanding inside of a for loop. So that means you could use a match the way I'm used to seeing it in like Rust, where it's just a freestanding thing. But notice like the way this essentially works. So in this situation, we're saying that match test is a function, and it's returning x. It's basically matching the value of x. That's an interesting syntax there, where it's kind of like using this equal sign instead of just like parentheses, curly brackets. I'm assuming that's part of the anonymous function syntax, which I'll get into later. Although it's a different, but it's also using the def keyword, so that's part where it's kind of different. But you're basically saying, okay, this function, what it does, it just returns the match of x. So it's going to take whatever you pass in as the argument, x, and then goes through the different cases. But now look, these cases are not just like, okay, hey, do they equal a value? Okay, like case 1 is it the number 1? Okay, so if it's the number 1, it's going to say 1. Case 2, is it the string of 2? And then it'll return 2. Now here's where it starts getting interesting. Now it's saying, is this a variable of type integer? So you're not saying, does it equal a particular value? You're saying, does it equal a particular type? And if so, it'll actually assign the value to a value y, and you can refer to that in whatever expression you're returning. And then the underscore just means basically your default case. Like what happens if it doesn't match anything else? Okay, then you put that. But in this case, you're defining a function so that way you can return the match. While in this example, you are just basically running a procedure. You're not returning a value, so you don't have to write it as a method. But here you're saying, okay, I'm going to match whatever this person thing is, and based on whatever this person is in this list object, okay, we'll do a certain thing. So again, here we're just not only specifying the type, but also the properties of it. So basically, in the definition of a person, because see right here we have a class, which is a person. And then notice I made a case class. This is a special type of class that's used for determining things in cases. So you can be like, okay, a person has a name and a string. Okay. And basically saying, okay, hey, if this thing is a person with the name of Alice and the age of 25, then you do this. But again, the last one, it doesn't matter if it has a specific name and age. It's any person with any name and age. And that is going to print this. And if we like that name and age gets saved to that variable. So it's a lot more flexible than a switch statement. That's one of the things I would really, really like for them to add to JavaScript. Okay, it's one of those things. I even built a library that kind of adds some level of pattern matching to JavaScript, and there's other libraries that do that too. And a proposal that's nowhere close to being added anytime soon. But yeah, it's definitely one of my favorite features that doesn't exist in JavaScript already. But that's here in Scala. Okay, so you can see what pattern matching is. And that's one of the things that can make it really powerful for working with data, because you can do a lot more flexible iterating through data and determining like how you're going to process that data, because you can have much more flexible matching with patterns. So that's like a very key feature of why people may choose Scala over Java. Like, does Java have pattern matching? I'm not sure if it does. Let's find out. Java pattern matching. I mean, also Java is just in general more verbose. Pattern matching for Java. Let's see here. The document is possible. Document exposes a direction for supporting pattern matching. Well, this is basically just saying to explain whether it's possible. Okay. Java feature spotlight. This is in 2021. Okay, so Java has introduced a limited form of pattern matching. So that's not until 14, which is not that long ago. I mean, only a few years ago I was installing 11, and I just recently updated to the JDK 17. Okay, permanent feature in SE16. And one kind of pattern, type patterns, and one language constructor instance of. This is the only first installments. Okay, so they have a simple pattern matching right now. So it's still kind of a newer thing in Java. So again, real pattern matching, especially again when you're working with large sets of data and you're doing a lot of processing and transformation, Scala or any language with this pattern matching feature can be really powerful. So I think OCaml, but again, things like OCaml I don't think necessarily by default work in the JVM. There probably is an implementation in the JVM. But yeah, so like it makes sense why Scala was picked for building out Spark and why it's sort of the best way to write Apache Spark scripts. But with that, I'm going to end this video because I think we've already covered probably more than enough for this video, but we still have lots of stuff to cover, and we'll get into that in the later videos. I'll see you then.